Welcome students. This is the second part of the topic data transfer or copy instructions of 8085 microprocessor. In my previous video of data transfer, you have seen these instructions from group 1 to group 4, and now you will study rest of the instructions in which group 6 are related to the stack pointer. So let's start with the PCHL and XCHG instructions. The first one is PCHL. In this instruction, here PC stands for the program counter and HL is the HL register pair. This instruction does not require any operand. Here, the contents of H and L registers are copied into the program counter as upper byte and lower byte respectively. It requires only 1 byte of the memory, and that is for the opcode of the instruction. Only opcode fetch machine cycle will be executed, but the size of this opcode fetch machine cycle is 6 T states. 2 T states are extra required to obtain the address of the next instruction. Addressing technique is register addressing mode. For more details on addressing technique, you can see my video on addressing modes of 8085 microprocessor. Now the next one is XCHG. This opcode is the short form of English word exchange. Here the contents of H and L registers are exchanged with the contents of D and E registers. It also requires only 1 byte of the memory, and the size of the opcode fetch machine cycle is 4 T states. Addressing technique is once again register addressing mode because operation is performed on the registers of 8085 microprocessor. Now before studying the group 6 instructions, let us first understand the stack memory. Stack is a group of memory locations in read-write memory. It is used to store the binary information, which can be any data or an address, temporarily during the execution of the program. Its size is limited by the size of the available memory. Now how it is initialized? Stack is initialized in the main program by using the instruction LXI SP 16-bit number. Here SP stands for the stack pointer. This is special purpose register of 8085 microprocessor. This register is used to locate the current stack location. This 16-bit number will directly copied into this stack pointer, and in this way the stack memory is initialized. But while initializing it or defining the starting location of a stack, it is preferred to assign the highest available memory location to the stack memory, because in this way programmer can prevent the overwritten of the data by the stack information. Now after initialization, the first data byte is stored at the memory location stack pointer -1, and hence you can say that a stack grows in the decreasing order. But while retrieving the data from the stack, it will be done in LIFO manner. LIFO is short form of last in first out. So this is about the stack memory. Now let's see its instructions. First one is push instruction. In this instruction, operands are register pair or program status word. This PSW is the 16-bit virtual register of 8085 microprocessor. Here the lower byte is the contents of flag register and upper byte is the contents of accumulator register. So in this instruction, the contents of these registers are copied onto the stack. Here second and third machine cycles are memory write because the contents of register pair or PSW are overwritten onto the stack memory. Students, note the point that the opcode fetch machine cycle in push instruction is 6 T states long. 2 T states are required extra to obtain the stack location. Addressing technique is register indirect because operands are indirectly specified in the instruction. Now let us understand this instruction with the help of a program. So first is initialization of the stack memory. So LXI SP 4099 hex. So 4099, next two memory locations are 4098 and 4097. We have taken the stack memory in the decreasing way because it grows in decreasing order. So stack pointer initial value is 4099. So here the stack memory is starting. Now the next instruction, the LXI H501C. In this instruction, the 16-bit number is copied into the register pair HL. After this, push H. So push the contents of HL register pair onto the stack. So in the first step, the value of the stack pointer is decremented by 1. So next memory location is 4098, and now the upper byte content of the register pair is copied into this memory location. After storing this number, once again stack pointer is decremented by 1. So next location is 4097, and now the lower byte of the register pair is copied into the stack location. So in this way, the contents of HL register pair are pushed into the stack memory, and the final value of the stack pointer is 4097, and thus the push operation is accomplished. Next is pop instruction. The pop instruction is performed just in the reverse manner as in the push instruction. Operands are same, register pair or PSW. Now the contents of the top two memory locations of the stack are copied into the register pair or PSW. In this instruction, the second and third machine cycles are memory read for reading the contents from the stack location and copying into the register pair or PSW. Total T states required are 10. Once again, the addressing technique is registered indirect. Now, example is pop D. So let us understand once again with the help of the same program. So we have seen up to this push H. So this is the memory, stack memory. And now for the pop instruction, stack pointer current value is 4097. And the contents at these memory locations are 1C, 50, and the contents of 4099 will not be touched because in this way you can prevent the data loss. Now the pop instruction. Pop the data from the stack memory into the register pair D. So this is a D register pair. In the first step, the contents of the current stack pointer value memory location is copied into the register E. So remember the point that the data retrieval is done in LIFO manner, last in first out. So we have seen in the push instruction that lastly the contents of register E, which is the lower byte of the register pair, is copied into the stack memory. So in case of pop instruction, the first step is to retrieve the data from the stack memory into the lower byte register pair. And after this, the stack pointer value is incremented by 1 to obtain the next location, that is the 4098. And copying the contents of this memory location into the upper byte register pair, and once again incremented by 1 to obtain the final location of the stack pointer. So we have seen that stack pointer is reached to its initial state. So in this way, pop instruction is executed. Next one is SPHL and XTHL instructions. SPHL instruction is very similar to the PCHL instruction. Here SP stands for the stack pointer. So in this instruction, the contents of H and L registers are copied into the stack pointer as upper byte and lower byte respectively. Once again, the opcode fetch machine cycles requires extra 2 T states to obtain the address of stack memory. Addressing technique is register addressing mode. Next is XTHL. In this opcode, T stands for the top of stack memory locations. HL is the HL register pair and X is signifying the exchange of contents from this top of stack memory location and HL register pair. Now let us understand this instruction with example. Let us suppose the contents at L and H registers are 5E and 92 hex, and the stack pointer and stack pointer plus 1 values are 4098 and 4099 respectively. So these 16-bit numbers are the stack memory locations. So let us assume the contents at these memory locations are 75 and 1A. Now according to this instruction, these contents will get exchanged. And after the execution of the instruction, the L and H will have 75 and 1A respectively, and the values at 4098 and 4099 are 5E and 92 respectively, which were the contents of HL register pair. So in this way, the XTHL instruction is executed. This instruction requires 5 machine cycles. Second and third machine cycles are memory read for reading the contents from the stack memory locations, and fourth and fifth machine cycles are memory write for writing the contents of L and H registers into these memory locations. Total T states required are 16. Addressing technique is register indirect because operands are indirectly specified in the instruction. Now these are the highlights of data transfer instructions. Now frequently asked questions from the topic. First one is specify the contents of registers and memory locations as the following instructions are executed. So these are the instructions. Next is why initial location of a stack should not be overwritten in push instruction, because in this way you can prevent the data loss. And the third one is what are the methods of altering the sequence of a program in 8085 microprocessor? This is very interesting question. Students, you can reply this in the comment section. Students, I hope you like the video. So please subscribe the channel for more contents, and if you have any queries, then write in the comment section. Thank you so much.